So let's talk about challenge number one, and challenge number one was the build automation. What was the goal of that challenge? So what we tried to achieve in the first place. So first of all, we need to build our code for each and every pull request. In addition to that, we need to run the unit tests for each and every pull request. In addition to that, we need to run the integration test for each and every pull request. And because our integration tests, they are platform specific, that means that they need to be executed for all three platforms, for Windows, for Linux, and for macOS as well. So what we did during the first iteration, how we actually handled our pipeline, what was kind of the high-level overview of it. So first of all, we used this kind of a definition for our job. So we defined our job that was named build, and we said, okay, it will run on the image called Ubuntu 16. And then what we did, we restored the NuGet packages for our .NET app, for our solution. Then we built all the projects, as you can see here, and then we, for example, run the unit tests. So this is more or less the pretty much straightforward way how you can organize your pipeline. What was the outcomes of the first iteration? So first of all, it works, which is already a good sign. But what we were not really happy about is that the build agent was defined on a job level, and the actions were defined on a task level. What was the learnings from this iteration? And here I would like to tell a joke. So where did you take this code from? I copied that from the Stack Overflow. Yeah, but did you copy it from the answer or from the question? So this was our learning. If we get back to the original goal of our challenge, the goal was to run those tests for each and every pull request for each and every platform. So with the approach that I showed to you before in the iteration one, we will need to basically copy all those steps for all the different platforms, which I was not really happy about. So that is why we came into the second iteration. And for the second iteration, we decided to use that cool feature that called the templates. So we defined the first template, as you can see here. So this template consists of basically two parts, the package restore and the build. And this was our kind of a definition, the group of tasks, how we built our app in the first place. And this was the second template that we defined. And this template was about running the tests. And this second template, as you can understand, we can use it for both, for unit tests and for integration tests as well. And those guys, as you can see, both of those templates, you can also define the parameters. In the first template, the only one parameter that we need, that was the path to the solution itself. In the second case, we choose two parameters, the path to the project with the test and the name. And why we need to name? Because what I also want to do here, I want to export all the results of my tests, and I want to have them as a part of the report, as a part of my build outcome. So that is why each and every test run I need to distinguish from another by providing a unique name. So how our pipeline actually looked for the second iteration. So this was the first part of it. So we defined some variables that then we will reuse later. So that was path to the solution, path to the unit test, and path to the integration tests. Then the next part, that was our job definition. So we defined our job more or less in the same way as we did before. But now what is really crucial about it is that we basically put the set of templates in an order that we need as a basically definition of this job. So we said, okay, first go to the template one, which is called template.build.yaml, and execute it with these parameters. Then go to the template called test and execute it with these parameters. For example, we provide the path to the unit test and the name unit test on Linux. The third step is to use the same template as we used before, as you can see here. So that's again template.test.yaml, but with the different set of parameters. And what was the outcomes of the second iteration? So first of all, it works And again, that's already a good sign if it works. But now we define our build agent at the job level, and actions, we define them on a template level. So there are much less copy and pasting right now is happening, and the solution itself is more manageable. If we need to change the approach of how we do in the test, how we export the results, how we integrate those results as a part of our build pipeline, we can easily do that into the template, and then it will be automatically applied to all the subsequent runs that we have in our pipelines. And on this point, let's actually go and see how it was implemented in Azure DevOps. So let's take a bit closer look on how you can implement those templates in your projects. So what you can see on your screen right now, this is the template for the build part. As you can see, it starts with the parameters section, and I have one parameter here, which is an empty string by default. Then I have the set of my steps, and the first step called use .NET, and my application is written in a way that it highly depends on the exact version of the .NET framework. So that is why I have this task here, and I set it to 2.1 latest version. The next step here is to restore all my NuGet packages. So I run .NET Core CLI command and exec restore command here, and as you can see, to the project's argument, I basically pass, using this notation, I pass the value of my parameter, pass to solution. The next step is the same .NET Core CLI, but now I run build command, and to the projects I basically pass the same pass to the solution file. And in addition to that, I also pass the key for the arguments no restore, because my dependencies were stored on a previous step. And I did that mostly for the demo purposes, because we all know that when you will run the build, if you don't have your NuGet packages restored, they will be restored automatically. The next part is for the test activity, and this is more or less the same template as I showed you before. Here you have two parameters, the name and pass to project. So pass to project, that's the parameter that I will use here. It will basically show me the path to the exact project with the exact set of tests that I want to run. But in addition to that, I also have the name. And the reason for that is because I want to run unit tests, I want to run integration tests for all the different platforms, and I then want to combine all those results, and I want to put them into my report for the build output. And to distinguish those results from one another, I need to provide a unique name for each and every different test run. So that's why I have this name parameter here. In addition to that, what I also want to highlight is that here I have continue on error equals true. What that actually means? It means that now my build can end up in 3 different statuses. So it can be either green or it can be red, and now it can be yellow as well. What it actually means? It means that if green, then basically all the tasks were successful. If red, then it means at least one task failed, but if that task that failed was marked with continue on error equals true, that actually means that all the other tasks will kind of be executed as well. So the build definition will not stop on the first fail as a default behavior, but it will be marked as yellow. So I can go later and investigate. I will know that something actually went wrong, but my build still finished. This is very useful to use for the test, because if your tests are failing, that can be an indication of either your logic is incorrect, or that also may be that the tests are incorrect. So that is why that's an indication for you to go and investigate it in more details. What I also want to highlight here, and this is one of the cool features of this .NET Core CLI task explicitly, is that I can also say publish test results equals true. So when I will run all my tests, I will then grab the results of those tests and automatically use them in my build outputs. If you are not using .NET, maybe you're using Java, Python, Node.js, whatever, there are still plenty of ways for you how you can integrate the results of your test runs into that final report. And one of the most popular ways to do that, I know that there is a format called JUnit, and a lot of tools for a lot of different platforms can export the results of their test into the JUnit format. And then if you export the results into the JUnit format, you can pick them up with the separate activity, with the separate task in your pipeline, and incorporate into the final report for your build run. Now I want to show you basically how it looks at the final pipeline. So this is my final pipeline. So I have the name, I have the trigger, and I have the PR trigger. What it actually means, it means that for each and every commit to the master branch, I will trigger this pipeline. In addition to that, for each and every pull request into this repo, I will also trigger this pipeline. Now I have the set of my variables here, and then I have my jobs. So the first job called Linux, and it will use the Ubuntu image, and it will execute the first template, which is template build YAML, with this parameter, and then 2 times it will execute the test template. And the reason for that is because I want to run the unit tests first, and then I want to run the integration tests. But the approach of doing those tests and the approach of incorporating the test results basically the same. The next job is Windows, and here, as you can see, again, I'm running it now on a different machine. I'm running it on Windows 2019. I need to build my project and I need to run my tests, but currently I am talking only about the integration tests. The next part is dedicated to macOS, and it's the same as for Windows. Build the project and run the integration tests. So this is basically how we address that part that we want to run all the integration tests for all the different platforms. And because this is the command line tool, then we can run the integration test on the agent themselves. And yeah, what we can do now, let's run this guy and let's see what will happen. So I will go click here, run, and I will run it. So now what we need to do, we need to wait for a few moments for this pipeline to be queued. And what I want to show you here is that, as you can see, I have 3 or maybe even more build agents available. So that is why all those 3 guys were queued in parallel, and they will be executed in parallel as well. So what we need to do now, we just need to wait for the results, and then we will analyze them together. Okay, so now we're here. Let's analyze the results of our build run. So as you can see here, there were kind of 3 jobs that runs in parallel: Linux, Windows, and macOS. Each of them took different time. And on top, I have a test tab. So let's go to the test and check what I have as my test results. So as you can see, that used to be 4 runs, and all of them passes, and in total it was 99 tests. And here, as you can see, if I scroll it down, hooray, there are no test failures, but that's because the filter, which is set by default, includes only the failed and aborted tests. So let's clear this one, and let's basically check what we have here. So let me just collapse this one. So as you can see, there is an integration test for Mac section, and I have like 5 tests here. Then I have integration test on Linux, again 5 here. I have integration test on Windows, and also I have unit test on Linux. So this is the way how the final report will actually looks like if you need to integrate all those tests from different build agents from different operational system, like I did here in this example. As I promised to you before, if you're using not .NET platform, but something like Java or Python or Node.js or whatever, you can still run your test as a part of Azure DevOps pipelines, and you can still grab the results and integrate them back to the pipelines and create the same reports that I showed to you for the .NET. So what I want to show you now, that's basically one of my old legacy projects where we still use pretty much a lot of old technologies. But anyway, what we were able to do, we were able to use Postman together with the component called human to basically create the collection of the API test and then run those tests automatically as a part of our release pipeline. So we can assume that you may be familiar with the Postman, but you may not be familiar with the Newman. So what you can do, you can check Newman on a GitHub. I will provide you this link as well. And here, that's basically what you will have. And then Newman, what I really like about it, that's basically the best companion for the Postman, and it's maintained actually by the same vendor as the Postman itself. So now what I have here, I have my Node.js app, and this app is based on the Azure Functions framework, but this is not the part of this conversation. What is really important here is that, as you can see, I have a human here in my dev dependencies, and also in my package.json file, I have this custom command, human test. And as a part of this command, what I'm actually doing, I'm running the human CLI, and I am basically providing the collection from the Postman with my API test. I also provide a set of variables that I need to run those tests. For example, that may be the host URL or the host port or whatever, or the target API that I will test with this collection. But what is really important here is that I ask it to export my results, my test results, into the JUnit format. And this is why it's actually important. Let me show you how the old classic release definition looks like. So it looks like this. And if I will scroll down, here is my npm run human test command. Let me also show you the YAML definition of this one. As you can see, that's basically the npm command, and I will execute the custom command here, and here I'm just referring to the run human test command. At the end of the day, the next step, as you can see here, is called publish test results, and this publish test results will basically create this fancy test tab for me. And as you can see here, overall I have 126 tests as a part of that run. Some of them passed, some of them failed. Let me just collapse this guy over here. So this is basically the list of the tests that were failing. I can check them and I can analyze them. I can do whatever I want. So the main purpose of this short demo was to show to you that even if you're not using .NET, that's fine. Azure DevOps is integrated really good with all the platforms that you may use, as I showed you here with the Node.js.